Hello and welcome everyone. Thank you for joining us today for our webinar titled Getting the Most Out of Your Machine Learning with Model Ops. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Dan Darnell is Vice President of Product Marketing at H2O.ai. Now before I hand it over to Dan, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and the slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Dan.
Great, thanks, Patrick. Well, look, there's a reason why we're here. Like, machine learning and the models that are created from that process really can't drive any value for businesses if we can't actually get them into production and use them as part of AI applications that can help us do things like, improve productivity, improve customer experiences, and just drive value for our business in general. So that's why I wanted to do this webinar, to talk you through how we can maximize the impact of machine learning through this technology called Model Ops. So who am I? Well, I'm Dan Darnell. As Patrick said, I'm working product marketing at H2O.ai. I've been in the analytics industry for over 20 years. I spent the past 9 years working exclusively on AI applications and machine learning platforms. And over the last 18 months, just before joining, or I should say rejoining H2O, I was working on the ML Ops or Model Ops issues and platforms. So I've written a number of articles on this topic area. You can see some of them here. And I'm pretty passionate about it, and I think need to share more information about this, hence why we're here today. So in this webinar, we're going to cover some of the challenges. I've talked with a number of people across the industry, seen a lot of different things that people are doing. So we'll talk about some of the challenges that people face. I'll introduce you to kind of Model Ops. So what are the key characteristics of Model Ops? I'll talk very briefly kind of about what H2O is doing in this space, and then I'll turn it over to you all for some questions. So artificial intelligence has really evolved from being a mere technology buzzword to the commercial reality that it is today. Now, AI is the ability for machines to perform tasks that people would normally do, like make inferences and decisions based on data, doing things like sorting images, responding to speech and text. I mean, hopefully everyone on the webinar or watching the webinar is aware of this. Our goal is to democratize AI, which means we want to bring AI to everyone across the business to make better decisions, to automate those processes, increase productivity, and improve experiences. And hopefully that's the same goal that you share. And to do that, there's a life cycle that we have to go through to develop AI and to introduce it into the business and get value from it. Let's take a look at that. So on the left-hand side, you can see that there's oftentimes, starts out, the business has a particular need or sees an opportunity to streamline a process or improve productivity, and will kind of start a process of saying, hey, could we maybe build a model or do something around this. Sometimes it's the data scientists at the top who find an opportunity and maybe go to the business. Nevertheless, kind of starting in the upper left, we have a use case where we see an opportunity to use machine learning typically, which has been one of the more productive areas of AI, to create an application or create a model which we can use as part of our application to drive these new insights. So we'll get up here in the data science portion. There'll be data exploration to see if we have the data to try and solve this problem. Do we have enough data to do predictions with reasonable accuracy, things like that. And or we may start to look for ways to augment the data that we have and say, okay, I don't have enough data, but can I go and augment my data with additional data sources, whether those are public or private? There's a lot of private data out there you can get access to maybe build a data source that I could build a model from. Then I get into that experimentation phase. Now I'm going to go through and iterate through a lot of different models, tuning parameters, the data that I use, et cetera, and try and find the best possible model for my use case, right? The one that has maybe the most accuracy, maybe the one that runs the fastest, maybe the combination of those two things. There's a lot of characteristics that you look for in that exploration process. And once I've done with that, now we're getting over to the right side of the diagram. I deploy that model out into production. Now, a lot of issues can arise there too. Take the model from maybe that was built on a data scientist's laptop. Now I'm going to bring that over and put it into production. So a lot of issues can occur there, just with productionizing or operationalizing the model, testing it and getting it up and running in the production environment. And then, of course, once I do that, a model that may have taken weeks or even months to develop can spend years running in production. And that's where you get into this concept of production lifecycle management, where I'm updating the model, et cetera. Now, of course, these various areas kind of interplay. Obviously, in that experimentation phase, there's a loop there where you have experimentation going back to data exploration. And similarly here, you have a loop where model lifecycle management says, hey, I need an updated model. Can you get an updated model and deploy it? Could be, hey, I need a new model version. Can you build that for me and push it back through the system, right? So there's kind of an interplay among all these levels. And then after you've got a solid production model, it typically gets integrated into AI applications or applications that exist today, so that people like call center agents, salespeople, marketing people can use that model to make better decisions, improve their own productivity, et cetera, right? So you see that kind of down on the bottom side. These people may say, hey, I need a newer version of a model. The process could start all over again at some point. And of course, once the AI application is built, there needs to be a feedback loop here with the app developer as well. And typically there's a pretty closed, tight loop here around iterating on the app and then updating the app going forward as new innovation happens in the business, and so on, right? So this loop of a process encompasses kind of all the things you need to think about in bringing AI and injecting AI into your business, right? At least at a high level. Now, today, we're going to talk about the right-hand side of the diagram, which is I've built my experiments, I've got a model I feel good about, and now I want to deploy that into production. I want to get it up and running and manage it in production. Okay, this is what is typically called the model ops or ML ops space. But there are a lot of problems on this side of the diagram. Otherwise, we wouldn't be here talking about it. This report that New Vantage Partners comes out with every year is a great one. They survey, in this case, they surveyed 70 companies. You can go look at it. They're all name brand, top-end companies that they survey as part of this. And not surprisingly, only about 15% of them have deployed AI broadly in production. And they cite, this is a quote, because this is where there are very significant people and process issues that come into play. In principle, or in reality, it's where your data science team and your IT team are going to have to work together. Neither one of them can do this job on their own, but there are significant challenges for them working together. They're just not living in harmony or interacting in a happy way. And there are a number of reasons why that's the case. The first is that these two teams just have very different mindsets in how they approach things. Your data science team is typically, creative, working with data, building models, trying to find that best possible model. And now that they've done it, they want to get it up and running and provide value to the business. On the IT side, they're focused on, hey, do we have stuff that's reliable, that performs well, that's secure? They're looking at kind of that performance, reliability, scalability, and security perspective, which is a very different viewpoint than what the data scientists are looking at. They also have really different kind of competencies, as you can see, and tool sets. You can imagine that if a data scientist were to come to an IT team with a Python model, or an R model, and says, okay, I've written this thing, it's in Python. There are a lot of IT teams who go, I don't know what that is. I don't speak Python, right? I do everything in Java and C++. We consider these to be production ready languages that we're comfortable with, and all our developers work in those tools. So a couple things happen at that point. This is the kind of classic throw it over the wall problem, right? Data scientist kind of throws it over to IT, and IT goes, we don't know what to do with this thing. And so a couple bad things can happen. They can just not do anything. They could rewrite the model in a new language, which you'll see is a really bad idea as we go forward here. Or they can try and, just containerize it and deploy it without understanding what it is. And they're going to be really uncomfortable with that, especially if you're putting something into more of a mission critical application. If they're putting code into production they really don't understand, right? So just different skill sets, different competencies, and different tool sets really that they're using. Both of these teams have very different resources. I mean, very limited resources. So if you look at your data science team, they're getting bombarded by requests across the business to build new models, to help drive AI, and to help the company transform and become an AI company. So they're very busy, right? And the IT team, similarly, the IT team is transitioning to the cloud, dealing with security, et cetera. You have two teams who are both really strapped with big demands on them that you're then asking to collaborate, communicate on something new, right? And neither one of them wants to take ownership of that process because neither one of them really has bandwidth or sees it as their problem exclusively, right? And that gets to the lack of ownership issue. So why is this a problem? Well, we are seeing a lot of disconnect between these two groups causing the issue. And as a result, you end up with some really interesting projects being deployed today. Let's take a look. So what does it look like today? If I have these two teams kind of in conflict or trying to work together, what does a successful project look like today? Because it does happen, right? We do get some projects up and going today. By the way, love this paper referenced on the bottom here. If you haven't read it, it's really the basis of a lot of what's going on in model ops and ML ops. It really kicks off the phenomenon, if you will, on hidden technical debt of machine learning systems. The reality is that the ML code, the model itself, is a relatively small part of the overall system that you need to run a model in production, right? You're going to need all kinds of other code and systems to run that model that need to be integrated and working together, right? And so today, when we deploy a model in production, we end up with kind of an intense and manual effort to get that model up and running, right? And data scientists, because they're the ones who understand the code, often have to be involved in that process. And so deploying a model can be an intensive process which involves IT people and app developers and the data science people writing code and all kinds of code being built, which you can imagine can make for a very brittle system, right? If I have a lot of custom code, if I have people who aren't expert production coders, that's one of those other issues that I forgot to point out earlier. Your data scientists are really good at building models, but they're not typically production coders, and they don't really know production issues well. Your IT team on the flip side understands production coding, but doesn't understand, how to code a model, right? So the two are going to have to work together on coding and getting this thing up and running. And when they do everything manually, you can get kind of a brittle set of things. And when it breaks, there's a mad scramble to try and fix it and figure out what happened, right? And when those kinds of mad scrambles happen, it makes everybody in IT really nervous that this thing isn't really ready for prime time, right? And so they want to put a very limited number of such things into the IT environment. So they might be willing to do a test with this kind of framework, but they're not really thinking of this as really production or ready to be integrated into their production environments. These systems that we have today, where we've done a lot of this manually, have limited monitoring. So we're going to have the same kind of monitoring we would have for software, like we would have things to monitor, how much compute are we using on this system, how much memory maybe is being used, is it responding, maybe how quickly is it responding, and those are all really necessary for monitoring of machine learning, but they're insufficient to know if a model is really healthy. in production. We'll talk about that when we get to discussing the framework for MLOps. And the ongoing management, as you can imagine, of the system requires a team of people, including some data scientists. And I have talked with people who are working on production projects that are kind of set up in this very manual way. And they say, my data scientists are spending 60 to 80% of their time on my production projects. I really, really need my data scientists to get back to doing data science. How do I do that? Right? So that's one of the key problems that we're trying to solve. Is we want data scientists to do data science and operations people to do operations, right? Another unfortunate consequence of this overall process is once you have success with a couple projects, 1, 2, 3, 10, 20, your executives will suddenly see the opportunity of AI in your business and machine learning. And they will say, oh, this is great. Look at the return on investment on our call center application or our marketing application. We want to do a lot more of that. And so instead of asking you for 2 or 3 or 4 more applications, they're asking you for 20, 50, 100 more models and integration into applications, right? So the excitement that the business has is great, but you can imagine the data science and IT people looking at that going, oh no, we cannot scale this thing that we built up to hundreds or thousands of such things, right? There's just no way. We don't have the people. We would have to add a ton of people. So obviously the answer here is, we need to scale some other way, right? But before I go on to scaling, I want to call this out as its own topic. Don't forget about governance. I wrote an article on this because I feel very strongly about it. One of the things that people do is they jump in to deploy models, to getting them up and running, and they completely forget that if a model is going to become part of a mission critical application for your business, and especially if you're in a regulated industry, you have to think about governance. You have to think about who is going to have access to that model to put it into production. Am I tracking what's going on with that model? Am I recording the things that are going on with that model so I can reproduce them in production? All of these types of things have to be thought out before you decide that you're going to put, especially mission critical stuff, into production, or you'll find that your project gets stopped at the last minute because someone will look at it and go, oh, you don't have checks on this to make sure that you're not putting something malicious, new malicious code into production, or that you're not introducing a model which is biased into production. There's a number of things here which you can see as needing checks depending on your business so that you can guarantee and minimize the risk and kind of guarantee that you're going to have a good outcome. So I wanted to call that out. So model ops is the solution. I mentioned it before. It's also known as ML ops from some people or ML ops from other folks. It's really a new set of technologies and practices, very similar to DevOps for software, but designed for machine learning operations, right? With model ops in place, you want your actors, your people in your business kind of doing what they're best at. You want your data scientists doing data science, you want your IT operations people doing operations, and you want them to be able to work together and collaborate where it matters. And when they do that, it allows your organization to kind of scale up with a governed process as you scale up your use of machine learning in production, right? That's really the goal of model operations. So model operations can really be broken down in any number of ways. We choose to look at it really in 3 pieces. There's the model deployment, which means how do I get that model up and running in my production infrastructure? What are the key pieces of that? That typically involves things like, putting it on, getting it up and running on Kubernetes, making sure that it will scale, that it responds on time, and all of that type of thing, right? So you've got that process of the production deployment piece. Then you have the model lifecycle management. So we're going to cover each of these in more detail, but model lifecycle management is, okay, now it's in production, it's up and running. Now I need to keep it healthy. right? So what am I doing to monitor it and make sure that it's running well? And if I need to do an update, how do I do an update, things like that. And the third pillar here is production model governance, not to be confused with your general governance efforts or your data governance, perhaps involved with those teams, but it's a separate effort that you need to consider around how am I going to maintain control over my models in production environment and reduce risk around having those production models up and running, right? So let's take a look at each one in a little more detail. So for production model deployment, I'll give you a couple kind of tips or rules here. The first one is, as we think about putting models into production, we're obviously bringing them from kind of an exploration environment into a production environment. Now, if you've worked with H2O before, you know that H2O thought about this a long time ago and has always had these kind of production model artifacts, which can easily be deployed and run in production systems. That's the Mojo, the Pojo, which is the Python, and then the model object optimized version. But that's something you've got to look for. You've got to look, okay, can I take my model artifact and easily put it into production? Can I scale it up, scale it down as I need to? So you'll be looking at things like Kubernetes, right? Am I running my model on Kubernetes such that I can deploy a number of pods and I can scale up and scale down? If I'm running a huge batch job, can I scale that up to get that batch job done in a few hours? If I'm running a real-time process or a streaming process, do I have the resources I need to be able to run that process as needed? Do I have the scalability of my infrastructure? The second one to look for in deployment is how easy is it for the operations side to access the models that need to be deployed? And oftentimes what you'll see is this is the throw the model over the wall problem, right? And a lot of times there isn't a connection between these two systems. And what you want, ideally, is as data science is ready to promote objects into production, the operations team has seamless access to those things. There's no possibility of the model getting lost in translation. It's just there and ready to be produced, if you will. And finally, I think the other thing to consider is that as you move into model ops, and a lot of times people forget about this stuff, but this really becomes a production issue. And you're going to need to be able to go through a standard IT process of promoting that code, because this is just code, from dev to test and prod. So you want to be able to set up multiple environments. You want to be able to promote that model, let's say, into a testing environment where I can run it through its paces and figure out that it's working well before I maybe put that into a production environment where it's actually going to see real requests. So you want to look for that kind of thing. Do I have the ability to go to dev, test, to prod, right? Those are the kinds of things I would think of when you're looking at the deployment infrastructure. And obviously there's more, and happy to show you what we've done with model ops, but these are some key things that I would suggest thinking about. Of course, once you get your model into production, I said there was a second phase here, which is really the operations lifecycle of that model, or production lifecycle management, where, and I could probably talk about this for hours, but there's a lot going on here. And you can imagine that from a day in the life perspective for model ops, this is where a lot of the action happens. You might be deploying a new model every once in a while, but those models, especially as you scale, you might have hundreds, thousands of them running in production. The big heavy lift is around the model lifecycle management, where you're monitoring those models and you're using tools for monitoring that are specifically designed to understand the health of a machine learning model. A good example of that is drift detection. So you want to have something like data drift, context drift detection sitting on your model and looking at the data that the model was trained on and comparing that to the data that you're seeing in production. Because if those two are different in certain way, if the important features of your model are seeing significant drift between your training data and your production data, that could cause your accuracy the accuracy of that model to decrease in production, right? So you want to have tools like that that will help you understand if your model is likely to be having issues. And that's really important if you have a model where you can't see the accuracy in production, right? If I make a loan in a bank and I want to determine if someone is likely to default on that loan, well, I won't actually know if they default on that loan until they do, 1 year, 5 years, 10 years later. So I can't necessarily get the accuracy of that prediction right back. It's not like if I did a product recommendation and I want to do a determination of whether someone clicked or not. I'm going to get the feedback from that model pretty quickly, and I might be able to use accuracy in that situation. But with things where the accuracy is farther out, I need other tools. And in that case, I'd recommend monitoring with the traditional kind of software approach, making sure that your model isn't consuming too many resources, but more importantly, making sure that the model is responding quickly, within your SLA with your downstream application. And I would make sure you have some drift monitoring so that you can see if the data that's underlying your model is drifting in significant ways. I'd also make sure that you have a way to share that drift information with your data science team, because typically you're going to have model operations with their own set of model ops dashboards, and you're going to have your data science team that's going to want to look at that maybe in more like a notebook format. And so you might want to think about ways to share that information back with your data science team in the tools that they already use. Now, the question is, when do you know to take a look, right? I think that's the next one, which is alerts. And keep in mind, if you have 100 or 1,000 models running in production, you are going to be managing this system by exception. You're not going to be in the dashboard every day looking at each and every model. You're going to want a system that kind of puts the guardrails around the models and tells you where you need to go look. So you're going to want to have a system, which really gets to the next two, but the first one is just you want to set up alerts such that if things go above a certain threshold, that people are notified, and you want to make sure those alerts can come in a couple different flavors. So this is a mission critical model. I may want to just have an email alert that goes out to people, every day that says, hey, your data is starting to drift. You need to take a look at your model. If it's a mission critical model, I may want to connect that up to more critical systems. Now, both of these, I might want to have Slack or some other system like that too, and have a group that's monitoring the model, and maybe I can subscribe to that. But in the case of a mission critical model, I might want to use something like PagerDuty or some other notification system that typically is used by the IT infrastructure team that will allow me to say, hey, there is a problem with one of these mission critical models, and someone needs to take a look at it. And you typically want to use that if you want to know 24/7 there's an issue with the model. So that's alerts. So you can imagine, I've got monitoring set up. I put alerts on top of that so that I can kind of manage by exception really around my models and go look at a model that has an issue. But that kind of belies the fact that your models will fail, in production. And so what are you going to do when that happens? So you want to have a framework in place for kind of failover and fallback, right? So within this life cycle of production, you want to make sure that when a model does start to exhibit issues, that you can either switch to another model or you have kind of failover conditions like rules that you can go to while you're fixing the model. The other thing I would say here is don't think that you're going to fix the model and then get it back up and running before anyone else notices, right? That's not going to happen. It's going to be broken. It's going to be hard to fix. Just assume that, and assume that I need to be able to switch to a safe mode while I kind of fix things and get things back up and running. And then updating models should be seamless, right? I shouldn't have to shut down the service and bring it back up again. Remember, your ML models are powering AI applications. Those AI applications are being used in your business. What you want to have happen is those people downstream don't even know that you had a problem. They don't even know that you updated the model, right? You want those updates to be completely seamless. And finally, as part of that process, you want to have testing built in. So you want to be able to do tests on a new model. Let's say I did have a problem. I introduce a newer version of the model to fix that problem. I want to be able to warm up that model so that I can make sure it works well in my production environment. I can make sure that I didn't introduce some bad code in that new version. So I want to make sure I maybe put it in a dev environment or a test environment, pound on it a little bit, make sure it's working well. And then I may want to move that into production and run a split test on it where I actually let it see some production traffic and actually provide some responses depending on the use case and see how it does before I give it the full traffic load, right? So there's a lot of testing that you want to put in place here as well. And that gives you kind of a breadth of the kind of things that your model ops people are doing day to day to keep your models up and running in model lifecycle management. Now, next is governance. We talked about this, and this is another key pillar of model ops. You need to look at kind of, first is who's accessing my stuff, right? You can imagine I put this mission critical model into production. I want to make sure that I have the same kind of access control, role-based access control that I have for other production applications. In fact, I want to integrate into the RBAC and directory structures that I use to control my business in general, right? So I can ensure that only people on my production team have access to production models and production systems, okay? The second is you need an audit trail. Especially if you're in a regulated industry, you're going to need a way to track who went in there, who touched what, and you're going to need that, especially if you need to reproduce what happened at some later time. Version control. So if I need to roll back, I'm going to need a version history. I'm going to need to know that this model version that I'm using is 1.5.1, and I can roll back to maybe a major version or a minor version. You're going to need a history, however you decide to do that, of the models you were running before. And that could be just a refitting, where I'm just retraining the model on newer data, but I'm not changing any of the parameters. It could be a rebuilding of the model, where I actually did change the parameters. Or it could be a brand new model entirely, a totally different model, but that serves the same use case. I need a log of all those versions, when they were being used, what requests they responded to, etc. And whatever the case, you're going to have to look at your business and figure out what controls you need to have in place for your business to comply with legal and regulatory requirements, right? So if you're in a heavily regulated business, these controls are going to be more rigorous. If you're not in a heavily regulated industry, they're going to be less, but you want to consider the legal ramifications and other things of what kind of controls you might want to put in place. Okay. Let's talk a little bit about the impact of model ops that you can expect from putting a model ops system in place. So the first one is, we talked about the issues with collaboration at the beginning of the data science and IT team. The goal here is to have a system where these two teams can work together, where they can collaborate and automate a lot of the process. Obviously, you want the systems to be kind of seamlessly connected together, so the data scientists can kind of work in their system that they understand, and the IT operations team can work in their system that they understand. You want to make sure you have effective use of your resource, because that will lead to significant cost savings, right? In terms of these people are really spinning their wheels right now, but it'll also lead you to be able to do a lot more. These resources will be able to build a lot more models, deploy a lot more models, work on a lot more projects, which will obviously have a very positive impact for the business. The second one is minimizing risk. And if you're not thinking about this, I'll just say it again, minimize risk, right? Risk, think about it. And really, this comes down to, let's all keep our jobs and let's stay out of jail, right? I mean, we do not want to be responsible for a big corporate blunder where we put a model into production that maybe had significant bias, or maybe even worse, we put a model that didn't have significant bias, but we get sued by somebody for saying we denied them credit, which they can do, and they can ask that we reproduce everything around that credit scoring exercise that led to their denial, and we can't do it. And then we're the people who are responsible for the company having to pay out in that case. Versus if we had shown a process around this And if we had all the controls in place, we could have reduced the risk, we could have created a reproducible process, and we could have shown that, no, our model was up and running, this is the model that was running, this is the result it produced, it's not biased, we've run all the checks on it, etc., which is what you want. And finally, we want to scale, right? I talked about this earlier, of people being able to do more of what they want to do. That's, hey, if you want to scale machine learning, you're going to need to scale in production, and you're going to be able to integrate that stuff into your other applications. To do that, it's got to be reliable. You've got to be able to count on it. It's got to be high performance, so you can count on it, again, when you're integrating it. And ultimately, you've got to be able to have a system where you can run many, many, many models. Because this isn't the kind of thing where, oh, to become AI-driven, we're going to have 10 models running in production. I can tell you from working with our customers, it's not tens, it's thousands or tens of thousands of such things running in production that will help you become an AI company. Okay? And when you do, it helps you increase, your profits, because now you've streamlined your business, you're making smarter, better decisions, you've improved the productivity of your employees, and you've improved your customer satisfaction and experience as well. So overall, you've become a much, much more profitable AI-driven company. So where does H2O fit in? One slide. Just so you know, of course, we are a leader in kind of the top section here across the industry with a number of products. I'm highlighting kind of H2O driverless AI, which is our AutoML. It's industry leading, allows you to do experimentation extremely quickly, runs on CPUs and GPUs. So if you have GPU related problems where that can help, it can run very, very quickly as you're exploring and building models and help you find that best possible model much, much more rapidly, literally in hours versus weeks or months. We're also rolling out our Model Ops product. You can see the logo here, which will allow you to deploy models, for example, the models being built by driverless AI or built on the H2O open source platform. You can deploy those out using H2O Model Ops. It has capabilities for testing those models, the dev test prod we talked about. It's seamlessly integrated with other H2O environments. So you don't have to, let's say, post the model up somewhere and then someone has to go download it or get it. They can just seamlessly grab it. And of course, we're working on the features and capabilities so you can manage that production lifecycle, doing monitoring. We've got a great set of real-time dashboards built on Grafana, so you can see the real-time data streaming in. You can see drift. And then we have other products over here on the other side that we have launched and we're building out to support things like data exploration, as well as the building and deployment of AI apps. But I wanted to let you know there is an H2O Model Ops offering, and if you were interested in that, obviously we'd be happy to talk to folks about that. So with that, I've kind of wrapped up my content, and Patrick, I'd be happy to take any questions with the remainder of our time if we have any.
Sure. Yeah, we've got some great questions here. We'll get through most of them as much as we can here with time permitting. The first one I'm seeing is, so which part of the life cycle is Lime involved with?
Okay, which part is Lime involved with? Yeah, let's go back up. So if we're talking about interpretability and explainability, there is a relationship between the building of the model, its interpretability, and the production side. And that's what I'm going to focus on right here. I think it's really important that as we have these interpretability techniques, which tell us how the model is doing in a specific situation, you have things like Shapley, Lime, and others that will allow you to interpret the model at a given point for a given prediction. Those are obviously needed as you're understanding the model in the exploration phase, but they actually come into use over in the production phase, because each time we respond to a request, we oftentimes want to provide the information, reason codes, as they're known in the industry, for that response. Why did the model respond this way? And techniques like Lime and others will give you, like, these were the characteristics that led us to, let's say, to decline the credit request, right? These were the top characteristics that led to positive impact and negative impact. So that's where you can get some of those explainability techniques coming into the production side of things. It's also really good if you have some of that explainability information available on the production side. In particular, it makes me think of our auto documentation or autodoc capabilities, which are available for both driverless models and H2O models now. We have a new product for that. And what's really important is to have that documentation available throughout the production process. Because what you want is, you may have a data scientist who built the model a while ago or on another team. That model gets pushed over into production, and I may be a data scientist working in production who has to look at that model now. Well, it'd be great if that documentation and the automated documentation is there for every driverless model, if you want it, were available on the production side, so they could just click it, open it, oh yeah, this is what they were trying to do. Oh, I now have an understanding of what this model is doing and why it's doing it, and I can better diagnose and troubleshoot. So that's probably more than the answer you were looking for, but there's a number of ways that kind of MLI can be integrated into the production side in a really, really helpful way.
Okay, great.
Other questions?
Thank you for that. Yeah, the next question is, how would you suggest that data science teams support model operations?
It's a great question because what I've seen, a couple things I would say. One, as a data scientist, you may have to get involved in the purchase process for model ops. And you may be saying, well, that's not really my space, and the IT team should really handle, what kind of model ops solution we look for, et cetera. But your IT team, one, is too busy to even know they need it. And two, you're the ones in the data science team who want this, to be honest, because you want to get out of the production business and you want your data science projects and products to be used as part of the business to drive value. So one of the things you have to do, and I know this probably wasn't the gist of the question, but I'll just say it, you probably have to be the one who starts to kind of raise the need for model ops within your company and say, hey, I learned about this topic. I really think we need to investigate and look at model ops, especially if we want to scale. And you may actually have to be the ones to do the initial evaluation. I would suggest partnering with IT at that point and say, hey, we're going to evaluate model ops solutions that we think would fit with our data science frameworks, of which you're probably using multiple ones. And then I would partner with the IT team, because at some point you're going to want them to take that over. So either in the selection process or once you decide who you want to work with, they're going to need to be the ones that run it. So at some point you're going to have to get them involved. On an ongoing basis, I think what you want to look for is just those interfaces between where the data science team can add value. Are there places where the data science team can interact directly with the model ops software? Sometimes there are kind of collaboration spaces where they can work together. The other thing is just look for ways that model ops can communicate back to the data science team. As I said, for example, can they publish something in a notebook format that a data scientist would be really comfortable reviewing and giving them feedback on, that kind of thing. I guess that's how I'd respond to that question.
Great. And we have a bit of an piggyback question on that, where you touched on data scientists and the IT department in particular, but this question is asking, how can we make the IT department and the DA department work together towards the same goal?
I'm not sure what the DA department is, I guess.
Maybe I'm referring to the slide, the data. Yeah, or data exploration augmentation, but
okay, maybe it's the data team, right? The data team, yeah. I guess. Yeah. So how can we get them all working towards the same goal? I guess it is a big challenge. Sometimes you have your data management team, which is very separated from even your data science team. And as you can see, that I could have put the data team between the business user and the data scientist. I didn't. And in a lot of organizations, there is a data management platform, which is run by data engineers who are responsible for building out the data jobs that are needed. And there certainly is a challenge of getting all of these people to work together. I think the most important thing is really making sure that at an executive level, so your CDO, for example, is bought into this overall process. And if you have a CDO, that they're aligning the teams, the data teams, both data science and data management, around projects that are going to make the most difference to the business. And that you've allocated resources towards those projects. And I guess that's how I would say I would line things up. I also think within this process, the data team and the data science team and the operations team, especially around this process, all have the same goal. And that's to deliver value to the business. So anytime you can kind of put this stuff in terms of value that they can provide to the business through their work, I think that's helpful. So I think oftentimes what you see is people saying, well, I don't know how this project is going to help the business, or how does it help me? So helping make sure they understand how it's helping them and how it's helping them build a higher profile within the company, and that people are going to see their work, I think is important. On a technical side, I will say this. There is a ton of data pipeline work that needs to happen on the production side. And that data pipeline work will not happen without the data management team in place and helping to support that process. So if you don't have them in the loop, you won't have the data pipelines that you're going to need to support your production process.
All right, thank you for that. Next question is, you mentioned failover. Are there simple options we could deploy for that?
Well, yeah, I'd say the complex ones are, as I mentioned, like having another model, having a secondary model running in production. Typically, it's a simpler model, one that you trust for a broader range of outcomes. So, maybe having your, GLM or something like that you produces generally broad, acceptable results, kind of running in the background is one option. If you don't have that, I've seen really successful use cases where the failover option was just either a rule set or a value. And I'll tell you what I mean by that. A rule set could just be, buckets. If generally the request looks like this, respond like this. If the request kind of looks like this, respond like this. So having the ability to fall back to a rule is good. It could also be a single value, right? Like if your model predicts how much RAM you'll need for a production server, right, that you're deploying and rolling out, it could be just the default is, well, give the server the maximum amount of RAM, right, for the time being until we figure out how much RAM it should have. At least then you know that you're wasting money, but at least you know it won't fail because you've given it the maximum amount you can, and that process will function and work. And then you can, after you fix the model and troubleshoot, you can go back, rerun that process and optimize the RAM, for example. So when you look at your model, make sure you understand, like, are there default values you could return if your model was failing, to give you some time and breathing room to go fix it. So I'd say those maybe rules, a rule set, maybe it's a fallback, which means you'll have some code kind of at the application layer potentially, that you'll maybe code in some of those fallback options. It could also become part of your model ops or ML ops solution, but it'll be in there somewhere. You'll have some kind of failover or fallback options built in.
Okay, next question. You are mentioning data scientists, but what about machine learning engineers? Aren't they more aligned with IT?
Yeah, that's a good question. The way I see and have seen machine learning engineers are people building algorithms, new algorithms. It depends. It's a new function, right? So the definition of what a machine learning engineer is varies across companies, much like the operations titles do. So I guess it depends on your company, right? Your machine learning engineers may be significantly aligned with your IT operations side, or maybe not. It just depends on what the role is and what they do. So again, it kind of comes down to your company and what the role of a machine learning engineer is in your business. But you're right, they could be. They could very much be.
Okay. In your experience, what kinds of scenarios are being deployed in production today?
Well, a lot. I think, the quote I gave earlier that, only 15% of people had deployed significantly in production. Another common one is that Gartner has said is that only about 47% of models are sustainably deployed in production, which means people are keeping things running well in production. And that was for models that were intended for production use. So there are clearly some challenges out there, but I don't want you to think that people haven't deployed stuff in production. I mean, H2O, one of the things I love about H2O is that there was a focus on low latency production scoring pipelines very early on, and it's kind of propagated through the technology set, which means that H2O's customers have deployed use cases and are running use cases in financial services and insurance and retail and marketing, all these different industries, and have them up and running in production and have had them up and running in production for quite some time. So in terms of the scenarios that people are doing, I think there's a lot. And I would suggest that, go to our website if you're interested in learning more, take a look at some of our case studies. Our customers are doing a lot with production models and having stuff running in production.
Okay. Are your customers deploying models in production? And could you give some examples of how they're doing that?
That's very similar to the prior question. Maybe I'll, yes, they are. And we just talked about that with Mojo's. That's principally how they're doing it today, which is they're taking the H2O model artifact that's coming out of either H2O open source or H2O driverless AI. It's being packaged up in a low latency model artifact called the Mojo, and that Mojo actually runs inside a framework which is built to run in a specific type of environment. So that Mojo gets pushed out. If you want to run that on in a specific runtime environment, there'll be a framework for that, and we publish a number of those. And then that model artifact is abstracted away from kind of the runtime framework, which I think is really important. You need that regardless of however you decide to deploy models. You don't want your model artifact to be tightly coupled with the underlying runtime artifacts, because then anytime anything changes in the runtime environment or the model artifact, everything breaks, right? And so we've done that, and people have deployed a bunch of models. Like I said, it's almost, you could look in insurance companies, tons of different use cases. You could look at financial services. I know we have insurance and financial services customers. Some of them have deployed more than 1,000 models against use cases that were built on H2O products, for an individual company. So there's certainly a lot. But it's the Mojo framework that has primarily driven that to date.
Great. Well, Dan, I think we'll end on that. I want to thank you for taking the time today and doing a great presentation. I'd like to thank everyone who joined us today as well. The presentation slides and the recording will be made available on our Bright Talk channel. And we hope you have a great rest of your day.
Thanks, everybody. Have a good one.